Hello students, let us discuss oxidation states in group 17 elements. All the elements of group 17 exhibit -1 oxidation state because they have 7 electrons in the valence shell. So it can easily accept 1 electron to form -1 oxidation state. So we can say that all the halogens exhibit -1 oxidation state. But the other elements like chlorine, bromine, iodine and astatine form positive oxidation state also. But fluorine always form -1 oxidation state. What is the reason? Why the fluorine always exhibit -1 oxidation state? Fluorine does not show positive oxidation states like the other elements of its own members. This is because fluorine has no vacant d orbital in its valence shell, therefore cannot expand its octet. Since the fluorine is in the second period of the periodic table, so the outermost shell in the fluorine is second. So when you write the electronic configuration, 1s2, 2s2, 2p, 5. So that means the outermost shell is the second shell, and we know that 2d is not present. So because of the absence of vacant d orbital in the fluorine, it cannot expand its octet. Just like the other elements of the same group, they expand its octet due to the excitation of electron to d orbitals. But fluorine have no such vacant d orbitals in order to expand its octet. So this is the reason for the anomalous behavior of fluorine, that is due to the smaller size, due to the absence of vacant d orbital, and because it is the most electronegative element. That is also an important point. It is the most electronegative element. So it will never form the positive oxidation state. It always form negative oxidation state because it is the most electronegative element. So whenever it combines with any other elements, it always form -1 oxidation state. But the other members of the same group can form positive oxidation state like +1, +3, +5 and +7. So how they form +3, +4, +5 oxidation state? That let us see some of the compounds in which halogens have +7 oxidation state like IF7. Here chlorine have oxidation state +5. Here bromine have the oxidation state +3. So the higher oxidation state of chlorine, bromine and iodine are mainly in the compounds with a small and highly electronegative elements like fluorine and oxygen. That is the compounds like IF7. Here iodine have the oxidation state +7. That is, it is having the higher oxidation state with the compound with the highly electronegative elements like fluorine. When it forms a compound with the highly electronegative elements like fluorine and oxygen, in such cases, the halogens like iodine, bromine and chlorine have higher oxidation state. Now why they form +3, +5 and +7 oxidation state, that we needed to discuss. So let us make the orbitals here. For halogen in the ground state, the configuration is Ns2, Np5. That is, in the ground state, that is the state in which there is no excitation. It is a ground state, that is a normal electronic configuration. Now when you look at the orbital here in the Np, there is a single electron here. So there is a single unpaired electron. Due to this, it forms -1 and +1 oxidation state. That is due to the presence of single unpaired electron in the Np it shows -1 and +1 oxidation state. But when one of the electron from 2p get excited to d orbital, so now you look at here in the first excitation state, how many unpaired electrons are there? 3 unpaired electrons are there. Therefore, due to the 3 unpaired electron, they form +3 oxidation state. Again, one of the electron from p get excited to the vacant d orbital. Now you can check in the second excitation state how many number of unpaired electrons are there? 1, 2, 3, 4, 5. Now there are 5 electrons, that is unpaired electron. So it shows +5 oxidation state. One more possibility is there here, that is one more that is a paired electron get excited. So due to that excitation, it shows how many oxidation state in the third excited state. 1, 2, 3, 4, 5, 6, 7 unpaired electrons are there. So therefore it shows +7 oxidation state. So because of this reason, that is the excitation of electron to the vacant d orbital, halogens can expand their oxidation state from +1 to +3, +4, +3, +5 and +7 oxidation state. That is due to the excitation of paired electron to the vacant d orbital. Since in the case of fluorine, there is no vacant d orbital, so this excitation is not possible in the case of fluorine. So we can say that it shows only -1 oxidation state, and it does not show +1 also because it is of highly electronegative element. So that is the most important point, that why the halogens can form -1 oxidation state, because of greater tendency to gain the electron in order to attain an stable configuration, that it shows -1 oxidation state. And the oxidation state like +1, +3, +5 and +7 oxidation state, it shows that is due to the excitation of electron to the vacant d orbital. There is 3 unpaired electron, then it is shows +3 oxidation state. When there is 5 when there is a 5 unpaired electron, it shows +5 oxidation state, and when there is a 7 unpaired electron, it shows +7 oxidation state. So that is the points related to oxidation state. Let us do one question, that is a textbook question. Fluorine exhibit only -1 oxidation state, whereas other halogens exhibit +1, +3, +5 and +7 oxidation state also. Explain. It is a textbook question, example 7.16. So just now we have discussed why the fluorine does not exhibit positive oxidation state, because the 2 point we have learned already, that is fluorine does not have a vacant d orbital in its valence shell, and the second point is fluorine is the most electronegative, so therefore it cannot form or cannot exhibit the positive oxidation state. But other halogens have the vacant d orbital, so excitation is possible, therefore it shows positive oxidation state. So it is one of the important question, that why fluorine does not exhibit -1, does not exhibit positive oxidation state like the other members of its own group. So this is about this question. So it is one of the most important point, the oxidation state, that we have discussed here for group 17 element, that is halogens. So this is all about this video. Have a nice day.